How are you all today? Are you enjoying the conference so far? Well, in this session, we'll learn how to build a data stream in 30 minutes, but obviously the session is 50 minutes. So before we get our hands dirty and write some code to actually build the data stream, let's go ahead and look at some of the concepts that build up this technology of data streaming. And we'll also look at some evolution in the data sharing economy that started when the web came about, and since then, where we came and where we are at presently, and why we need this sort of like streaming architecture in our applications. Sounds good? So I'm Srushtika Neelakantam, and I work as a developer advocate for Ably Realtime. Any of you have heard of Ably? Okay, so Ably offers a real-time messaging architecture as a service that you can plug into your applications to incorporate real-time or live functionality, to build applications like live HQ trivia, like quiz, or online collaboration like Google Docs, or location tracking applications and such. In my spare time, I volunteer for the Mozilla Foundation, where I'm involved with a couple of programs like Tech Speakers, the Reps, and the Campus Advisory Committee. I'm also a co-author of a WebVR book. If you have any questions or want to talk more about any of these things, make sure to catch me later. I'm going to be around in the venue. So as I said, in this talk, before we get into building a data stream, let's look at how things have changed since the web came forward. Obviously, everything started in the late 1980s and 90s when Sir Tim Berners-Lee invented this thing called the World Wide Web. And with www, there came the possibility of two nodes participating on this internet, and even though they were geographically distributed, they could still communicate with each other over this internet. With more and more people participating on this internet, you wanted some kind of governed rules or set of protocols, so everyone followed those rules and there wouldn't be any chaos. And thus came the HTTP protocol that we all use, which sits in the 7th layer of the OSI model, giving the network services to the applications that we as JavaScript developers build. Now, we all know how HTTP or Hypertext Transfer Protocol works, right? There is a client and a server. The client is requesting for some resource from the server. How it works is the connection is set up by the client, sends the request, the server processes the request, sends some response back. The response could have some data or some service that the server has computed on the request. And then the connection is closed. Now, we know that HTTP is stateless, which means that if these two same entities want to communicate with each other again, you need to set up a new connection and repeat the process of request and responses. While it worked fine for the applications back then, things have been changing. But before we get into that, let's right now start to put everything that we are looking at on a linear graph. So by the end of this talk, we have an abstract view of where we started and where we are headed. So let's call it the evolution of the data sharing economy, and let me put down websites. So with HTTP coming forward, it opened up the opportunity for a lot of businesses to put their services online and to reach a wider audience, basically. So people would then request resources from the website and get requests back. And this became really popular, right? Not only for the business that put up the website, which was hugely benefiting from wider reach and greater sales and all of that. Consider an e-commerce website, for example. But even customers could now access information and data from the comfort of their home without needing to go out, and they could just click buttons and get access to any kind of info they needed. But with this came a lot of challenges, as a lot more and more people started using these websites. So there was obviously the problem of traffic management. When a lot of people started using websites, there was a need to manage this traffic in some way or the other, and the businesses that put up their websites were asking their engineering teams to deal with this issue and implement some kind of a traffic management implementation as a layer on top of the basic website. Now, with traffic management, there came the concept of caching, where you could reduce the load on the server by just introducing some mechanism, some entity in the middle that could store the resources that were being asked again and again and not disturb the server all the time. So then the engineering team was busy with building this caching layer that would sit in between the client and the server. And then there came the concept of storage. Obviously, all the assets, the pictures, the data, everything that was being served had to be stored and hosted somewhere, and it needed to communicate with a server among themselves, which would then present the final result to the users when they requested for something. Now, every company that was trying to build a website or an application was dealing with the same scenario. They were asking their engineering teams to build the exact kind of functionality layers on top of the basic implementation, and every team was building it from scratch. While all of this was happening, a couple of people were observing this trend, and they said, hey, wait a minute, why are engineers reinventing the wheel? Why not we implement these layers once and then provide it as a service to multiple companies so they don't have to start it from scratch all the time? Thus came the concept of CDNs, or content delivery networks, which basically took off these functionality layers that would sit on top of your basic implementation and provide it as a service. Now, users could request and get responses back directly from the CDN. Obviously, in a lot of scenarios, it is white label, so you don't actually know you're talking to a CDN. It still feels like you're interacting with the company itself. A couple of companies then started providing CDN as a service, and I'm sure a lot of us have used more than one of these. Now, this worked well and fine for the REST-based, HTTP-based applications that we had, like the e-commerce website that I was talking about, where you click on a button, essentially sending a request behind the hood, and getting some data back and then displaying it to the user. Some static data from the database or some computation done on the fly based on some user input. But if you see nowadays, we're using more and more applications which are event-driven. What I mean is something happens in the real world and we would like to know about that happening immediately, ASAP. And that's sort of like an event-driven model of data sharing. And you may also call it real-time data sharing. Consider the Uber application. As the driver is moving on the streets, you want to know the location in real time with no delay or minimal latency. And by minimal latency, I'm talking just a couple of 100 milliseconds. So with the HTTP scenario, it doesn't really work with us, right? I mean, think about how would you make it work in the stateless scenario. The immediate thing that you would think is to get new updates is maybe refresh the page again and again, essentially sending new requests, which is essentially HTTP polling. But then obviously the whole connection setup phase, requests and responses just adds to the latency and does not help us in any way for the kind of minimal latency applications or event-driven applications that we are interested in. So then logical step forward from polling, HTTP polling, is something called long polling, where you're still doing the same repetition of connection setup, requests and responses. The only difference being the server is able to keep the connection open for a little longer before it sends back the response. So what happens when you're doing HTTP polling is sometimes the server may not have any new data to send back to you. So it may be sending empty responses all the time. So at least in long polling, it minimizes sending of empty responses in a way that it keeps the connection open until it has some real data to send back in the response, and when it does, it sends it back. But obviously, even in this scenario, if the data is taking forever to come to the server from the data provider, the response obviously will be returned back as empty response. But even though, like we looked at HTTP polling and long polling, none of these scenarios really fit into the kind of applications that we are talking about. They still add to a lot of latency and don't fit the kind of application models like location sharing without the client interacting with the application or sending requests anyway possible. Now, if you think about it, it's the server every time that has access to this data and needs to send it to the client, and the client doesn't magically know when some data is available, but we're doing it all wrong. So that's when, in the mid 2008, there came an idea called Websockets, which emerged as a protocol, which by 2011, most of the browser vendors were compliant with. How it starts, obviously, you can't expect, since the web emerged, every entity on the web is compliant with HTTP. So you can't expect all the entities participating on the internet to magically support this new protocol. So how WebSockets works is it initially starts off as the HTTP request. The only difference being in that request, you include an upgrade header telling the other party that, if you're compliant with WebSockets protocol, let's upgrade this connection. If yes, then in the response it says yes, and then a full duplex persistent connection opens up, which means that the client and the server can now communicate with each other simultaneously, and the communication can be in both directions. And the connection is persistent, meaning the connection can be kept open for as long as the application is running, and it could be indefinite as well. This, if you see now, the server has an open avenue to talk to the client whenever it has some data. And it can just tell the client, hey, you know what, you asked for this data, and I know you're interested, so here's the data that you need. It has a way to communicate to the server and sort of implement the kind of push mechanism that we talk about versus the pull that was mostly working with HTTP. So how can you implement WebSockets in your own applications? Obviously, you can build it from scratch by specifying the upgrade header and everything in the HTTP protocol, but why reinvent the wheel again? There are a lot of open source WebSocket servers that you can spin up in no time to incorporate this basic WebSockets functionality or real-time functionality within your applications. Socket.io, I'm sure a lot of you would have heard of. It is the most popular, very easy to implement, and very robust technology. Obviously, one more thing to note here is WebSockets is not the only protocol that you would use for event-driven or real-time kind of applications. There are other protocols like MQTT, which is a lightweight version of WebSockets, which is more useful or suitable for battery-constrained devices such as IoT sensors because it is lightweight. And there is server-sent events, which is not really full duplex. There is no two-way communication, but it is still a push mechanism where the server is capable of pushing some data to the clients. So which of these protocols you would use in your application really depends on the use case. For every use case, the particular protocol would be just beneficial because there's no one solution. But obviously, WebSockets covers majority of the use cases when you talk about real-time applications. So let's go back to the online data sharing economy graph that we were putting together. We saw websites back then which were working with HTTP and had all of those complexities that were solved by something called CDNs. Websites now would like to incorporate some live or real-time infrastructure within their application. So just to be clear, when I say websites, I'm also talking about mobile applications, all right? So for websites or applications to incorporate real-time functionality, they would ask their engineers to build this real-time infrastructure, which should be using one of the open source solutions that we saw, or building something from scratch, etc. So engineering teams spent time in building this architecture on top of the basic website functionality that was built. And then with that came the concept of fan out. Now in REST, we had something called caching, but in real time, you don't really have the concept of caching, right? Because there are no stored resources. Everything is happening live. The data is created and it is just distributed to everyone that's interested. So kind of like the equivalent of caching is fan out, where you publish the data once and then the data is fanned out to every entity that's interested in getting that data. But obviously the number of people interested in getting that same data shouldn't affect the publisher of that data in any way. So that's where the fan out implementation comes about, and the engineering teams started spending time on implementing that as a feature on top. Then with that, obviously, came the scalability. Now, the scalability in REST is very different compared to real time, right? In REST, it's kind of like an expected scalability. You have time to deal with it, add more nodes, etc. But with real time, everything happens in spikes. So in 1 second, you might have your different clients sharing, say, 100 messages. In the next very second, they may be sharing 1 million messages. So everything changes so quickly, and you need to adapt your scale up and scale down as quickly as well in order to not add any latency. So that's a huge complexity, which again the engineers wanted to build on top as a functionality. The same thing happened where every application that was wanting to incorporate real-time functionality was building these layers on top of their basic implementation. And a couple of people who were observing this trend said, why again are we reinventing the wheel? Like CDN provided those functionality layers for HTTP-based websites. Let's take these out and provide it as a functionality and implement it once so multiple companies can communicate with this and work with it. Now this is called Data Stream Network, or DSN, which basically is an abstraction of distributed systems architecture, which makes sure there's no fault tolerance implemented, there's a spike-based scalability implemented, and all of the complexity bits that we saw. So just kind of visualize it. What happens is, it's not really clear, but what's happening inside the circle, it's an abstraction of a distributed systems architecture. And all of your devices, front-end or back-end, servers, databases, sensors, mobile phones, or vehicles, anything, they kind of connect to this distributed systems architecture in a plug-and-play fashion, which means that they're completely decoupled from each other. They just plug into it, subscribe to some data, and start receiving something, or they just plug into it and publish some data. And how many other people are listening to that data or receiving that data is completely, they don't have to worry about it, because that is dealt by the distributed systems or the data stream network that is there in between. As we saw, those are some of the companies that provide data stream network. So a lot of communication in the real-time or event-driven architecture follows the pub-sub or publish-subscribe messaging pattern, where you have a publisher and a publisher, or many publishers, or many subscribers or one subscriber. And basically, how they share data is in logical units called channels or topics, and every channel carries different kind of data. For instance, as you can see here, the location channel obviously carries the location data, and the other channel carries the job updates data. And the publishers just publish into the channel, and then they don't have to worry about anything else. And the subscribers, when they subscribe to the channel, they are just pushed that data. So they don't have to keep requesting for new updates again and again. It's sort of like the magazines that we subscribe to. You subscribe to it once from the shop or whichever vendor is selling that, and then it's just like delivered to your place all the time, and you don't have to worry about it. So let's have a look at a quick example. Do you have your phones connected to the internet? If you can take out your phones and visit this link, go.ably.io/comment on your browsers, and feel free to say things, good things, I hope. So basically what I've done is this has subscribed to all the comments that you're posting. So I'm not refreshing the page, or I'm not fiddling with it in any way, but since it's already subscribed to the data, it should potentially show the comments that you're publishing right now. Is anyone connected? Oh yeah, we have a person called Mother of Dragons saying hi. Yeah, awesome, that works. So basically, you get the idea, right? You're all publishing to this channel, the same channel to which my application is subscribed to, and I've not refreshed it or sent a new request at all. It's basically all real time, and that's how event-driven applications work. And if you now go back and think about the Uber application or whatever that we were talking about, this makes sense, right? You have both or all of these entities connected together in a persistent fashion, communicating with each other all the time, or for as long as the application is running. So let's go back. Cool. So back to the graph again. Now, we saw how HTTP-based applications work. We saw how event-driven applications work. But while all of this was happening, there was this, I'm sure you all remember, there was this era of APIs or application programming interfaces. People said, hey, you know what? We create really interesting data, and we could potentially share this data programmatically with other developers who could utilize this data and build some other cool applications with that data. Basically, we have a deal with a company, and obviously, it's our data, so we'll charge for it. And that's how both of the companies will benefit. And that's when the API, the era of APIs came, and everyone started building APIs for the data that they owned. So people could just tap into the API and just start using the data. Obviously, as REST APIs started coming forward, people were sending requests and getting responses back from the APIs. But as APIs were programmatically being accessed, it is really difficult to figure out the kind of traffic that the APIs were attracting. So obviously, the engineering team that built the REST APIs for a company had to deal with this thing called analytics, where it automatically recorded the numbers of how their REST APIs were being used, and the different demographics, etc. All kinds of analytics, which is really important for a business to move their APIs in the right direction. And then there's obviously rate limiting. You can't have one developer or a company hog all the resources, making it unavailable for some other company or developers. You have to implement some kind of a rate limiting setup in your API, and that layer came on top. And again, there is this essential thing called access management. You can't have all of your data be accessible to everyone. You need to segregate it in some way, add security, authentication, and all of that. So all of these functionality layers were built on top, and every company wanting to make their data available as an API was dealing with this. Guess what happened? Just as the history keeps repeating, a couple of people said, this is the same functionality everyone's doing, so why do it? Implement it once and provide it as a functionality to multiple companies. And that's when the API management tools came forward and said, okay, we'll provide this functionality on top of your REST API, and you can then go ahead and make your APIs available and just focus on what you do best, which is your business or creating that data, which is the most valuable part. So I think what we've seen until now is where we are currently at in the data sharing economy. We have event-driven applications, we have HTTP-based applications, we have REST APIs and everything. But right now, what people are realizing is that they're looking at this trend and saying, with HTTP-based websites, people could essentially access the data programmatically by sending requests to the APIs. Why not do the same thing for real-time data? Thus came the concept of streaming APIs or event-driven APIs or real-time APIs. And people could now make the data that they provide, for instance, consider a temperature sensor that's sensing this data all the time. Now, it would maybe create a live stream and share it with other businesses who could use this data to build some applications which would then be used by the end users, right? So they wanted to, provide this as an API, as a stream. But obviously, there were some of the, same kind of difficulties that people building REST APIs faced. There was obviously analytics and rate limiting that was supposed to be implemented, which is, as we saw in REST API, is very important. But with real-time APIs, there are some other kind of complexities as well, such as adapters and protocol interoperability. As I mentioned, Websockets is not the only protocol in real time. You have multiple protocols. With REST, you had one thing, HTTP, and everyone interacted with HTTP. But in this, you can have a sensor working with MQTT, wanting to communicate with a web page, working with WebSockets. And you need to make sure both of these are interoperable and they're not adding to any latency. And adapters is, with real time, you have all of these different systems that you now need to plug your application into. Say you have an AWS Lambda function that you would like to invoke when some event in the real life happens. So, how do you incorporate all of this? You ask your engineering teams, obviously, to build these, functionality layers on top. Same thing happened. A couple of companies came together and said, you're just doing this from scratch. No need to do that. Let's be more efficient and provide this as a functionality which we'll call real-time API management tools, or streaming API management tools, or event-driven API management tools. You can basically refer to it in any way that makes sense to you. And a couple of companies then started providing it as a service that you can now use to make your real-time stream data available for other companies without needing to worry about the complexity of A, sharing the data in real time, and B, managing that data by implementing all of those functionality layers on top. And this is not an exhaustive list of the functionality layers, obviously, but some of the most important ones that you need to definitely implement. Okay, great. So I've talked enough. Let's actually go ahead and write some code. So what we'll do now is we'll write some code to build a data stream using one of the data stream networks, which is Ably, because obviously the title says with Node.js, VanillaJS, and Ably, so everyone understands what's happening. And let's go ahead and do it. I'm going to just sit here and quickly mirror the screen so I know what's happening. Okay, awesome. Cool. Can everyone see the screen? Sorry, there's nothing on the screen. Okay, so can everyone read the code? People at the back? Awesome. So what I'm going to do is quickly show you, to access the Ably DSN, obviously we need an API key, so I can just quickly show you how to do that. I'm not going to do it and waste your time. Basically, log in or create a free account. You get 3 million free messages, much more than enough to build hobby applications and use it with your friends. Basically, after you've created an account, you get a private API key, and that's what I've got. So I've copied it here, and what's happening here is that I have a publisher instance and I have a subscriber instance. Subscriber is in VanillaJS, publisher is using Express with Node. What we'll see is the kind of application that we built, but here we'll try to build an example data stream by just publishing new time every second. Yeah, very creative, but let's just say it works for this session. Okay? So as you can see, this is right now serving the root URL, where it is serving the index.html, which is literally just this text, so nothing to see there. And when we say publish, it will just say, hi, I'm now publishing, so we know what's happening. In the server, obviously, we have express for root for publish. And this is where we'll write our code to publish data. Before we get started, we need to connect to Ably, require it as a node module. Okay. And now we'll initialize the library with the API key. So let's just say new ably.realtime, because there's a REST client library as well that you can use for just publishing or only authenticating your devices. So you have Ably realtime and the API key that I got after creating an account. And there I've instantiated the library. So now, as I said, in a data stream network, all of the data sharing happens in terms of topics or channels, right? So let's go ahead and create a channel. Const, let's call it my channel, simple and easy. Ably.channels.get, let's call it time. Again, very creative. So what I'll do is we'll publish, we'll generate new time every second and publish that on this channel. So let's go ahead here. Before this, let's create a function that generates new time. Function get new time. Okay. So let now is equal to new date. And let's say let new time equals now dot get hours, now dot get minutes, and now dot get seconds. Okay, great. And let's just return this. Return new time dot toString. Okay, now let's do it here. Now, as I said, a data stream network, any data stream network that you would use would essentially reduce all of the complexity that is involved with sharing of data in real time, right? So what we'll do is write a single statement here which says okay, so my channel, because we want to publish the data on that channel, dot publish, let's say new time is the event that I'm publishing, and it's just get new time, and that's it. That's literally it. But obviously this only publishes the time once, right? So we want to repeat this every second, so we set an interval. Let's put that in there. Also, for us to know that this is happening, let's also log it every time so we can see if it's in fact publishing at all. Okay, so if I open the logs now, The server is running. Obviously, we haven't changed the URL to publish, so it doesn't do anything at the moment. And when I say publish, it's now publishing the time. I can just add a space here, so it looks a bit better. Okay. Now, it's just a single statement connecting to the data stream network and start publishing onto a channel after you've instantiated a channel. The same thing goes for your subscriber, where we have a plain index.html file where I literally just have a box where we'll display the results. And the script.js is empty. I hope it loads. Still waiting. Okay, so let's go ahead and say Ably equals, so if you see, I've already added the Ably CDN script in the index.html, so it's ready to be used. Ably new ably.realtime. The same thing, because we're, for the sake of simplicity, let's go ahead and use the same API key, but you can, assign different API keys for different clients that you work with. I mean, all of this, if you remember, data stream network is used for communicating with different clients within your own application or organization, right? So for the sake of simplicity here, I'm using the same API key. I've instantiated the library, and the same thing where we say my channel equals ably.channels.get, which was the channel we used. It was time, so we attached to the same channel to get that particular data. And then we just say, we see in index.html, which is result time. It's identified by that, so let's just say result box equals result time. Is that the same ID? Okay, perfect. And let's just go ahead and add. So what we've done here is we've instantiated the library and attached to the channel, but we never subscribe to the channel, right? So we need to do that first, where, let's comment this for a moment, where we go here and say my channel dot subscribe, and as you get callback, you just display it in the result.text box. .text message.data, simple as that. So if there are no errors, this should work. Okay, there are no errors, but it's not working. Oh yeah, okay. So I'm using this tool called Glitch, which is really useful for demos like this, but it doesn't autocomplete your code. So if you're used to with Visual Studio Code, which just closes the bracket for you, this becomes a problem. So as you can see, whatever we are publishing the time here is being subscribed to and displayed in real time here. And even if any of you want to look at it from your mobile applications, if you just go to ijs-subscriber.glitch.me, you should be able to receive the same kind of time again. But in any scenario, the publisher or the subscriber don't have to worry about the other participants that are part of the same channel or are receiving this kind of data. All right, so that's basically what we saw in terms of DSN. Is that the presentation? Okay. So we can also look at the kind of streaming APIs. So the kind of the time data that I was providing, I could potentially provide it as a stream to other companies to use from. Obviously, no one would be interested in time, but if you were actually generating some really useful data like the sensor data I was talking about, you could potentially provide it programmatically to other users. So you would use real-time API management. Let's have a quick look at it using Ably's API streamer. I'm not going to show you the same thing again, but basically what happens is you can switch the dashboard to using API streamer compared to the DSN that we until now chose, where you can literally create a producer, which means you're a producer of the data and you create a new product, which means this is the product or the stream that you will be sharing with other companies or developers, all programmatically with all the management functionality that we talked about automatically. Just fill out the profile details, description of the product. We'll just call it this product publishes new time, and people would be really interested in it, hopefully. You can provide the documentation. Now, the difference in this documentation is that the channel in the other one could be anything that we wanted. But here, there is a certain kind of syntax where you say product, followed by the API display name of the producer, followed by the API display name of the product that you've created, followed by the channel namespace in which you would like to publish that particular kind of data. So you can just say that. So all of this documentation will be available to the consumer or to the company that you're providing this data to. And after you've said, make this product, it will essentially create the product, which I can now add subscribers to. So for instance, a company now comes to me and says, I would like to use this stream. So what I would do is go back to the dashboard and add a subscriber. So if I go back to the products, subscriptions, add a subscriber, and I would just fill out the details of the person or the company that I would like to, I have commercial agreements with, and I would, specify the pricing details and everything, license, subscription license, and all of that. And obviously the message charge, because you are sharing your data in terms of an API and you would like to charge. Maybe they will be paying for the data on their own, or maybe you will bear all the charges. It completely depends on the commercial agreements you have with this other group of developers. And when that is done, the consumer will receive an invite, and when they just accept it, and fill out their consumer profile. All of this basically is when they fill up the consumer profile, they can accept the invite. And basically what happens is that they now have access to use data from the channel that we saw earlier, which is product, API test, IJS, whatever the channel that we created was. It essentially just added access to that kind of data. Now, if we go back here and have a look, basically, if you kind of add the streaming API management set that we saw here, as well as the DSN together, you kind of get an end-to-end benefit, because now you're not just managing a real-time messaging architecture that you already have, but you're using the same functionality to build that architecture in the first place, and then just adding management functionality to it. So it's not like two different services that you would use, one for this and one for that. So it kind of becomes easier when you have one company. To make it more clear, you would place DSN in between here, where the clients within that one organization would communicate with each other via the data stream network. That would be, say, company A. And then you have another company which again internally would communicate using DSN, and that would work. But then these two companies to communicate with each other programmatically is where you would use the streaming API management kind of tools, which basically gives you kind of an end-to-end benefits, where the end user in one of the companies can now communicate with the end user in the other company without really passing through multiple multiple shares of data. Basically, it's a single stream where everyone can plug into, with the right access, of course. The internet is a place where all the data is flowing, all the time, and it is predicted that in the next couple of years, the data that we produce and consume is going to increase threefold, and 30% of that new data is going to be real time. So I think it's really high time that we understand the various kind of options we have. Obviously, as I said, we have HTTP and real time. It does not mean that we're moving only towards real time. HTTP is still relevant and is available for the kind of use cases that are relevant for it. We just need to know the availabilities or the possibilities and use the right protocols and technologies for our applications. That's all I had. Thank you very much.